Hey guys, I just did a Zoom call with some of you and intended on posting just the recording of the Zoom call, but it would not load. So here we are, starting over. Um, so what we're learning in this lesson is about reference angles. And so reference angle is defined here at the beginning, in very technical terms. But I'll just give you the short version. So a reference angle is how far your current angle measure is from the x-axis. And it's a measurement that's going to be given in degrees or in radians, depending on what was given in the original question. So I'm going to give you an example to start with, and then we'll go through just a whole bunch of examples to kind of help you through it. So it says the angle shown below is 210 degrees. The reference angle is what? So I want to remind you real quick that when you're graphing an angle, you would go up for a positive angle and down for a negative angle. And then remind you that like a quarter of a turn is a 90-degree angle, a half a turn is 180 degrees, 3/4 of a turn is 270, and then a full rotation is 360 degrees. So this angle's already been graphed for you at 210. You'll notice it's just slightly past the 180 mark, okay? Now the reference angle would be the distance from your angle to the x-axis, okay? So essentially what I'm going to ask you, I'm going to mark this is 210. Essentially what a reference angle is asking you to do is to kind of tell how far you would need to go in degrees to get from the x-axis to your angle. So this is at 180 degrees. How far do I need to go to get down to here? Well, this is at 210, right? So to get from 180 to 210, I need to go an extra 30 degrees. So 30 degrees would be called the reference angle. So 30 degrees is called the reference angle. All right, let's just keep going through examples, as many as we can do. So we're going to first graph 150 degrees. So remember, angles always start on the positive x-axis. And what I would really like to see you do is every time you're getting ready to plot an angle, I would like to see you marking the 90, 180, 270, 360 as like your checkpoints until you really feel comfortable with this stuff, okay? So I need to graph 150, and that's positive, so I will be moving up first. And I know that 150 is somewhere between 90 and 180. And so I'm going to do my best to kind of graph where I think 150 would be. That I think that might be too sharp of an angle. Let me see if I can turn that a little bit. So I think it's probably going to be right about there. Okay, so 150 degrees would be coming around this direction. Okay, so the reference angle is the distance from that mark to the x-axis. So if I'm currently at 150, how much further do I need to go as an angle to get to here? Well, this is kind of like a 180 turn, right? It's a quarter of a way around the circle. That's 180 degrees. So if I'm at 150, I would just need to go an extra 30 degrees. An extra 30 degrees to get to the x-axis. That's a 0. So 30 degrees would be called your reference angle because it's how far you have to go from the angle you're at to the x-axis. Okay, 315 degrees is our next one. So I'm going to go ahead and mark these key points. And again, if you're still not real comfortable with graphing angles, you're going to want to go back to lesson 5.1 for graphing in degrees and lesson 5.2 for graphing in radians. This unit really builds upon itself, so you have to really master one skill before moving on to the next one. Okay, it's super important. 315 degrees. I know I need to go around the circle, definitely past 270, but stop before I get to 360. So 315 degrees. Remember, this is like your starting point. 315 would be right about here. And I always like to show like which way I moved to get to that line. So we would go up and around. So that's your current 315 degree angle drawing, and then I want the reference angle. So the reference angle again is just how far are you in degrees away from the x-axis. So this time the x-axis is right here, and the x-axis is called 360 degrees. So basically if I were to go all the way around the circle, I would land back on the x-axis, but as an angle measurement, that's 360 degrees to go all the way around. Well, I'm not quite there. I'm only at 315. So then the question is, how much further do I need to go to get to 360? So kind of what I'm pointing out is that you could just do simple math by saying, what's the difference between these two values? That's essentially what I'm asking for when I say how far to get there. And that just means subtract. So I need to do 360 minus 315 to find that answer. And that should be 45 degrees. Okay. Negative 120. Okay. So here is the starting point. Negative angles, remember you go down first. So I'm going to adjust my little checkpoints to accommodate for the negative angle. So negative 90 would be down here instead of 90 being up there like before. Okay, so where's 120? So 120 is going to be a little past 90, right? A little bit past 90. So here would be negative 120 degrees. All right, and I want a reference angle. So reference angle is distance to the x-axis. So think of it this way. I'm at 120. The x-axis is at 180. That's what it says right here. So how far do I need to go to get from 120 to 180? You can just subtract the numbers. You have to go 60 more degrees to get to 180. Now, some of you are probably thinking, is that supposed to be negative? No, it's not supposed to be negative because a reference angle is just a distance measurement, and you don't measure distances in negative values. Like you wouldn't say that you are, I don't know, negative 3 miles away from something. You're just 3 miles away. So really the negative is more just a directional component. It's not really a measurement that affects your distance. All right, 140. So we're going positive again. So we're going to go up this way and around. Okay, 140 is going to be past 90. I don't know, I'm going to guess right about there. Okay, so that would be 140 all the way around to here. And then what's your reference angle? So again, distance from that mark to the x-axis is how much? Okay, this time I'm at 140. The x-axis is at 180. How much further do I need to go in degree measurement? I need to go another 40 degrees. Okay, so we're going to switch gears and we're going to look at radian measure. And so here again, I want to tell you, if you are not comfortable with graphing these angles, if you haven't watched the videos in enough detail yet, then you need to stop this video now and go back and watch those lessons from 5.1 and 5.2, especially with the radians. If you are still not comfortable with what a radian is, you need to pause and go back and do that again, because this is going to be reliant on you understanding lesson 5.2. Here we go. Okay, so I need to graph 3 pi by 4. So in lesson 5.2, we learned that a radian, pi radians is equivalent to a 180-degree rotation. So over here where I would normally put 180 degrees, I am putting pi, okay? And maybe I'll put 1 pi. So a half of a rotation is considered to be 1 pi radians, which means a half of that movement, so a quarter rotation, would be considered a half of a pi in radians. And then a 3/4 turn would be another half, so 1.5 pi's. And then all the way around would be 2 pi's. Okay, so each axis, each 90-degree movement is a half pi in radians. And again, I want you to write these check marks or checkpoints at each axis, just so you kind of have a frame of reference for what's going on. Okay, I'm going to graph 3 pi over 4. Actually, let me move this up a little. Now, to do that, what I taught you in lesson 5.2 was that you're going to separate the fraction from the pi. And so I'm going to say, where's 3/4 pi? Well, 1 pi is all the way to here, and half pi is at this mark. So where would 3/4 fall? Is 3/4 larger than a half? Yes, it is. Is it larger than 1? No, it is not. So it'd be somewhere in between. Wow, look at that. That was a terrible line. Somewhere between a half and 1. And in fact, it should be right in the middle, because 3/4 is directly between 1/2 and 1. But, you know, just a sketch is fine for now. Okay, so for your reference angle, we're looking for the distance to the x-axis. This you're going to have to use your ability to understand fractions a little bit, and for some of you, I know that will be difficult, so I'll try to give you different strategies for how to get through the radian measure reference angles, but I'm going to start with this. So I'm going to say, I want to know how far this angle would be in radians. I am currently at 3 pi over 4, or maybe we should just say 3/4 of a pi. And to the x-axis would be 1 whole pi. So if I have 3/4 of a pi, how much more would I need to have a whole pi? Well, I would need 1 more quarter. Okay, because 3/4 plus 1/4 equals 1 whole. And 1 whole is like this x-axis here in radian measure. So your reference angle for this one is going to equal 1/4 of a pi. But a better way to write your answer would be pi over 4. That's just moving the pi back inside of the fraction rather than having it separated. So there's one option, okay? Option 2 for how to handle this would be, if you're not comfortable with like completing a fraction to make it 1 whole, what you could do instead is take what you want, which is 1 pi, and subtract what you have, and you have 3/4 pi. Okay, and then really the pi parts of it don't matter. What really matters is that you just figure out what's 1 take away 3/4. And you could use a calculator to do that, I guess. Although this is, you know, we are juniors and seniors in high school, most of us, so we should be able to figure this out. But, you know, if not, you can use a calculator. If you're not using a calculator, this would be, you know, get a common denominator, and you get 4 over 4 minus 3 over 4 equals 1 over 4. So that's where the 1 over 4 part came from in our solution. Okay, 7 pi over 6. So I'm going to do this one like I did last time, and that is split the fraction up away from the pi. And then I'm going to do one more step on this example, because 7 over 6 is an improper fraction. And so if I write it as a mixed number, it would be 1 1/6. And 1 1/6 pi is going to be right past the 1 pi mark. So just a little bit past, like here. And my reference angle would be the distance to the x-axis, and I went to 1 1/6. So this would be 1/6 pi as my reference angle.